Good morning, guys. I want to give you some notes on solving polynomials. I'm recording this with Screencast-O-Matic for a couple of reasons. I want to bounce back between Desmos and the Elmo. So first thing I'm going to do is we've got this polynomial right here, 8x cubed minus 2x squared minus 43x plus 30. Solving polynomials is also called finding zeros. Okay. Now, what I want to do first, I want to look at it with a graph. So I'm going to go to Desmos, and I've got it graphed right here for you. And I'm going to move the graph a little bit. There you go. So it's this curvy-shaped function, and finding the zeros of a polynomial means that you're looking for where the graph crosses the x-axis. Well, it looks like it crosses right here at 2, 0. And if I go over here to my table, okay, right here, it says that the ordered pair 2, 0 is on the graph. It also looks like it crosses somewhere between 0 and 1 right here. Again, I look at it, it tells me it's at 0.75. So there, that point is right there, 0.75. 0. Again, anywhere there's a 0 in the y column, go back to the x column, and that's your answer. Okay, that's your solution you're looking for. So 2 is a solution, 0.75 is a solution, and right up here, negative 2.5 is a solution. Negative 2.5 is right over here. Okay, these are also called zeros of the function. Okay. I'm going to go back to Elmo real quick here, and we're going to, if you pause the video and just sketch that graph here, that would be great. I'm not going to sketch it because I don't want to use up all the time on my video, but remember, negative 2.5 was one of our solutions because it gave us a value of 0. It was where the graph crossed or bounced off the x-axis. 0.75 was also one of our solutions because it gave us a value of 0. And lastly, 2 was one of our solutions because it gave us a value of 0. Okay? So we know those points, 2, 0, 0.750, and negative 2.50 are all on the graph. Now, just go ahead and finish sketching that graph from the Desmos. You could also use a graphing calculator. Guys, your TI-36X Pro will give you some of these zeros. And we'll look at how to do that in class a little bit. Just go to Table, type in the function, and look for 0 in the y column. Solving polynomials means finding values of x which will make the y value equal to 0. Okay? I'm going to zoom in a little bit here. Okay? On a graph, that means determining the x value where the function crosses or bounces off the x-axis, because the x-axis is where y is equal to 0. Okay? On a table, that means looking for 0 in the y column and then matching it to the value in the x column. Once you've begun to identify one or more zeros by using a graph or a table, by the way, zeros are also called solutions, and you'll see this repeated so many times so you don't get confused. They're also called x-intercepts, meaning where the graph crosses the x-axis. Once you've begun to identify these zeros, you should use synthetic division, I'm going to abbreviate that here, to determine a new, simpler polynomial which is easier to solve. So I'm going to do some examples of these problems in a little while when we get done with the notes. Okay? Press pause anytime you need to slow down and just listen, or rewind and go back and listen. Okay? All right. Typically we might factor, so once we do synthetic division to get a simpler polynomial, then we go back to what we learned in Unit 1. We might factor the polynomial to solve it. We might use the quadratic formula to solve it, or we might even use the square root method to find the remaining zeros. Remember, zeros are also called what? Solutions or x-intercepts. How many zeros should each polynomial have? Well, that depends on whatever the degree of the polynomial is. Okay? So if it's a 4th degree polynomial, it should have 4 solutions. If it's a 3rd degree polynomial, it should have 3 solutions. Okay? So to recap, we're going to try to find the zeros by looking at a graph or a table. Now, sometimes to make things easier, the instructions may start you out by giving you one of the zeros, also called a solution. Use any zeros you find or are given with synthetic division to simplify the polynomial, and then continue to solve the new polynomial using methods from Unit 1, factoring, quadratic formula, square root method. Or if you don't mind the agony, you can complete the square. I doubt anybody will choose to do completing the square to find the remaining zeros. Just a couple things that you need to remember. If x plus 2 is a factor of the polynomial, then negative 2 is your zero. If x minus 5 is a factor, then 5 is your zero. If x minus 1/2 is a factor, then 1/2 is your zero. If 3x plus 4 is a factor, negative 4 over 3 is the solution. Remember, reverse bottoms up there. We talked about that a couple times in previous units. Also remember, if negative 7 is a zero of the polynomial, that means x plus 7 is a factor. If 12 is a zero of the polynomial, that means x minus 12 is a factor of the polynomial. If 1/3 is a zero of the polynomial, that means 3x minus 1 is a factor of the polynomial. Okay? All right, that's the notes. Now we're going to apply these to some problems in the next video. I'm going to go ahead and upload this so you can be working on the notes. And I'll start a new video shortly and I'll upload that. All right, guys.